Hi, good afternoon. Hello, my name is Josh. Thank you for inviting me, and thank you for coming to my little talk about 3D printing, 3D design, prototyping, kind of all those topics in kind of one. Uh, what this presentation is kind of a record of my last 8 months of work. It's kind of an interesting story, and it talks directly to exactly what the title is. So without further ado, let me just talk a little bit about who I am, brief background, that sort of thing. I'm an artist. I went to school to go to art. I actually just graduated from Salisbury University, got my BFA there, and kind of like these are all things I've made with 3D printing. It's all stuff I designed and printed for my artwork. The big giant heart there and me on there on the side was probably the first big project I ever did, and was actually my first reason why I got into Fusion 360 to do anything in the first place. And so that was for the International Folk Festival back in 2015. It feels like we're 16. I don't know. It's all blur. But anyway, these are all 3D printed objects. These are all things that I've created. These are all things that I'm into. And then after I graduated, I moved. I got a little job at the Salisbury University's Entrepreneurship Center, the Rommel Center, and I work at their makerspace. They hired me to kind of maintain their printers. I had a lot of experience with these things, and I knew what to do. And as I was spending time there doing printing, I started encountering people coming in that, because of the Entrepreneurship Center, of course, they're entrepreneurs, but they had a need. They had these designs, they had these ideas they wanted, but they didn't know actually how to design it, or they didn't know how to get from point A to point B. And so I started a side business with the Rommel Center to do this design work and do this kind of work. So these projects I'm showing you are actually some of the projects that I've done. And we'll talk about processes and that sort of thing and the software. And behind it all, years and years ago in a previous lifetime, I used to work in healthcare, an IT consultant. I would train the doctors how to do stuff, but that's boring. We're not here for that. So let's get into some stuff. For my method, I just kind of want to pull this out there because I kind of talk about how I get into things and how I get into into 3D printing. It's pretty straightforward, at least from my point of view. I actually do the old-fashioned I draw it out thing. I guess it's my old practice of drawing these new ideas, these new features. Hey, come on. And so I spend the time, sit there and coffee or somewhere else and just actually draw the thing out. Then I take it to CAD, something like Fusion 360, which is the software I'm familiar with the most, and then go to 3D printing. 3D printing, which we'll cover a lot more detail, is a wide topic, and I have lots of anecdotes so we can share. And then finally, testing and iteration. All these screenshots are various from different projects, but you'll see some more of this as we go along. But I just wanted to bring that up because it's that flow kind of, it's a little bit cyclical, and meaning that sometimes it comes back, especially after design and testing, you may have to come back and redo the design. That's probably the most common thing I have to do. Anyway, let's look at some stuff. I'm going to do this was a real simple project, but I wanted to kind of talk about identifying and finding a need. This is for Belinda Parsons. She's a registered nurse who works at a methadone clinic up in Lewis or somewhere in Delaware. She works there, and she came to me. She says, we have this machine, this dispensing machine, and when it dispenses, the motor inside shakes the whole box, and the tube that dispenses the methadone spills everywhere. You know, it just makes a big mess, and it costs money, and it's a controlled substance and that sort of thing. And so her workaround was, well, I just took a pen cap and popped a hole in it and stuck it in the hole, and that's her workaround. I need a practical solution. I needed something to be built. This was really simple. It took a minute. So what we did is we go into Fusion 360. I took a design of the pen cap and wherever fit, did a quick design, 3D printed it out, and she installed it on her machine. This was real simple. This was a nice, easy one because they're really just emulating a pen cap. But Melinda is actually looking now to possibly, does this thing have a purpose? Does it have a value and in it that it does save materials? Could this be something like a patent, something I could sell, or at least looking at building her own methadone dispensing machine to address those issues. This is a nice, simple one, but I wanted to kind of start off a little slow. This next one, I call this the cow cam. And this is David White, and he works, I think he works here at UMES, and he has his company SciCam, or Tomorrow's Bio Today. And he approached me to do this project. He has this vision of a camera device that the cow swallows, goes through the cow and takes pictures of it. This is for veterinary medicine. And he needed someone to help design the casing, the actual shell for that cow to swallow. Never thought in a million years that's something I'd work on. It was a unique opportunity, and I know how to design. So it was a good exercise and chance to kind of explore. So this on the screen is my CAD rendering of the final design, but we'll take a look at some of the details here in a second. The goal was to take existing electronic components. That's in the top left corner of your screen there. That's the battery, that's the board, that's the camera and the antenna and that sort of stuff. Try and arrange it in the most compact way possible, and then kind of in the lower left-hand corner, build the shell around it. And these are all renderings from Fusion 360. On the right, I have some renderings of the actual device, the actual shell casing. And in the bottom right, this is my interesting trick with ABS, the type of plastic I use to print with this. If you use acetone vapors, it actually kind of melts the plastic without actually melting it, like with fire. And it creates a nice shell, seals the whole thing up. So kind of an interesting thing about 3D printing, when you think about it, as I have the printer chattering away, it's just drawing layer by layer, right? Layer up, drawing. That makes it terrible for waterproofing. So it's actually not waterproof until you do something to seal it up. So these are kind of one of those final steps. So the goal of this product is to have the electronics. They feed it to the cow. Don't ask how. It goes in the cow, takes pictures of its journey, and then transmits it out into a Wi-Fi device the cow wears, and then sends it to a satellite. And then eventually it makes its way out, and they retrieve it wherever. Details I didn't really need to know, but that's why it's red. If you're asking, the cow cam. It was a very interesting, brief project, but it also kind of demonstrating the need and then doing the design work to actually make the thing. Actually, I should have started with this question. Just a quick show of hands. Has anyone? Well, I know Pammy told me. Has anyone else have not used a 3D printer or used a 3D printer? Has anyone used a 3D printer before? A couple of folks. So a lot of folks are just brand new stuff, right? When I'm saying 3D printing, that's good for me to know, so I can kind of scale it back. 3D printing is, for all intents and purposes, prototyping technology. It was built in the 80s to facilitate factories and design groups to make items to test before you go through the laborious and very expensive process to print this stuff. In the last 20 years or so, these kind of personal desktop kind of type printers have come into the market using materials like PLA, which is a type of plastic, or ABS, which is like Lego plastic. And what it does, essentially, it's a precision hot glue gun with a computerized arm, melts it, and then draws out the shapes. And what we're going to see is a couple quick examples of how it does that as I get through my talking about it. All right, cow cam. And this one, actually I'm kind of proud of, is the Clean Wave device. This is from Imani Hassel. She's an engineering student. And she, through TEDCO, got a grant to do development of her device that she pitched. And as you can see on the screen, there is the actual rendering of the actual thing. The ask was for a toilet seat that cleans itself in between uses. It's something to be installed in an airport or a bathroom at a public area. And it's battery operated, and so it doesn't need to be plugged into anything, and something that'll last and be quick. When I got the idea, there was literally nothing really to kind of work with other than that's what we want. And then I had to kind of go through and make it. And so this is a good project to show, and I can talk about it a little bit more. These are some of the final design details. It's a complicated device. And this is one where I had to hire an additional mechanical engineer to take me over the hump of electric uses, motor power, that sort of stuff. I mean, I know a little bit, but I'm an artist more than a mechanical engineer. And the part of prototyping is sourcing and resourcing folks that have the expertise. And Dimitri was well worth it. So this is a picture of the actual design. Ideally, this is kind of like an interior diagram. It's kind of a cutaway view, kind of the back view. And I brought this in for fun because, you know, I'm just talking about it because it's in my car. This is the actual thing. This is the actual parts for that thing. This is that front part. This is the back shell. I don't have the doors on it. This is all being sent out today to my mechanical engineer to help me assemble the final product. So I wanted to share this. It's kind of neat. And actually, if I'll just put it out if you want to take a look, touch it. This is a giant 3D printed thing. Here, I'll go ahead if you want to. I'm not going to bite. If it does, you can bite back. This is ABS plastic. This is just the same plastic that you use for Legos. It's a big rub my cleaning toilet piece, right? It's kind of fun. Yeah, touch this. This represents 4 solid weeks of printing. 4 solid weeks. This is my January into February. I'm very happy to get this out of my desk. But for the ask of the client or my mechanical engineer, when you think about it, think about 3D printing, you notice that this was it's kind of large, right? And if you look at this 3D printer here, it would be hard to print this on that because it's a smaller device. So 3D printers come in all shapes and sizes and different types. This is a large format printer. It has the square footage of it's pretty much a square meter printing zone. It's pretty good. And the only issue is it takes forever to print. Like this one back shell here was about 8 days solid printing. And I'll show some examples of when things go wrong a little later. But this is actually going to go into the final prototype. That's where Imani is going to take that and use it to help pitch and get more investment to that device. And it's come a long way. It's important to talk about is iterations. That's why 3D printing is kind of an important thing, because it allows you to kind of make things without committing to the whole process the factory has to go through to make like a mold, an injection mold, or whatever it is the design. On the screen are a couple of different previous versions of this design. Top here on the top is my original pitch idea for the thing. It was very much just a simple arm that goes out and sprays the lid of the toilet. They didn't like that so much. I have another version where the back end kind of folds over and then this drawer comes out and washes the toilet seat. My mechanical engineer thought, that's too much. So that's what brought us back to this design. So the Clean Wave device is probably the more interesting one I've worked on so far. Challenging because printing stuff in this size is all sorts of problems. Yeah, any questions? If you thought I saw, and let me know. I'm happy to play improvise. Okay. So here's a couple examples to show, and here's some work photos. The top left, you'll see the gigabot I was talking about. In order to make this thing happen, how do I say this? 3D printing can be a nightmare to use. It's actually kind of, I say that lovingly because I do love it, but at the same time, it drives me crazy. And for example, this particular material, ABS, is very, very temperature sensitive. Remember, it's a hot glue gun squirting out plastic in a precision drawing over and over and over again. And the temperature of the environment matters. Like looking at this printer right here, this is printing ABS right now. It's all enclosed, and if you were to walk over here and feel it, it's cooking. It's like a little oven. It's keeping the internal temperature at about 100 degrees Celsius-ish. I don't remember exactly. Unfortunately. So you can boil some water in there. The reason why you do that is, as I'm drawing layer by layer, sorry, camera's over here, layer by layer, the bed is hot. The plastic you just came out of your extruder is hot, but all those layers in between get cool. And if it cools too much, then things start to shift. Things happen. And you get this little kind of tilt and mess up that is inevitable. You may have noticed it even on these prints, these little cracks. That's all from that snow nonsense we've had the past month. That's the day it got super cold and the snow dropped. I can tell it's like a things on a tree. It all depends on the temperature. So on this printer, you may notice, what's this tarp? What's all this crap? I had to make a chamber because it's a big giant printer to emulate this to make it an oven so that when I print the thing for 6 to 7 to 9 days, it comes out, because all the previous prints, they all failed until I built that thing. And then over here, you can see that giant mess. That was my last week, clearing all the supports materials. So 3D printing, this particular style of 3D printing is called FDM printing. It's fused deposit manufacturing. And it's essentially that. Fused as in it's plastic strips, it's depositing, and it's manufacturing. It's just hot glue gun. When it comes to using 3D printers, you have to have a design to actually throw in the machine. And these are a list of some popular 3D design softwares that I have some experience with. And if you want to take note of a couple of these, I really want to highlight. Fusion 360 is it's a good one, and it's powered by Autodesk. It's kind of a standard. Same with SolidWorks. SolidWorks is also an industry standard for design and manufacturing. These other ones are a little kind of on the looser side. Cinema 4D is a high-end 3D modeling, usually primarily used for CGI graphics. But I do a lot of my modeling in there sometimes because it has some interesting tools where I can play with the shape. It's a little more artistic style. Blender, you may have heard of Blender. It's free. Blender is free. Check it out. It's like the free version of Cinema 4D. It's clunkier, but it works just as good. And the one I really want to highlight to you, and I want to pull up here in a second, it's called Mesh Mixer. Mesh Mixer is a good entry-level software program. If you're like, I want to try 3D modeling, but I don't want to deal with all the craziness, like there's too much. Like when you open up Blender, you're going to see the screen's just full of buttons and stuff, too many options. But Mesh Mixer is clean, it's simple. Shape 1, shape 2, stick them together, you got shape 3. I'll show you that. So if you're interested in trying and designing your own work, Mesh Mixer is a good starting point. Also, Tinkercad, you may have heard of that one. Tinkercad's good. Fusion 360, Mesh Mixer, Tinkercad are all part of Autodesk. It's all part of that Autodesk software suite. So these are good softwares to look at. I would recommend, again, Mesh Mixer for beginners, Fusion 360 SolidWorks for engineers, Cinema 4D for artists, and Blender for everyone else in between. So talking about 3D printing and prototyping, there's actually like 6 or 7 types of printers out there, but the ones we talk about mostly are FDMs and the SLAs. The FDMs are the plastic ones, the ones that squirt out plastic. The SLA ones are the resin printers. Have you seen those? Where they have it's like a big, like a pool of resin goo, and the board goes into the goo, and there's a laser and it draws in the goo, and that hardens that little layer, and it just dips and repeats and dips and repeats. Those are the best printers in the world. Those give you the cleanest, detailed stuff. We're moving to getting one of those right now at the Rommel Center, and I'm looking forward to it because Those printers, I can actually print ready to use functional parts out the box. I don't have to do anything. It's a little bit of a higher trick. There's a lot more functionality or a lot more processing you have to do with those because it's resin. You have to kind of wash it and cure it. It's like a process. It's doable. So when you're thinking of prototyping, you have to kind of, what's most important really is the material. And it all comes back to, what are we making? What's this for? The reason why we chose ABS for this particular project is ABS is durable and it has high strength. It's flexible. It's actually probably the preferred plastic, and most of plastic things in here are probably ABS. It's an industry standard. It's easy to mold. The other types of filament that these printers use is called PLA, which is a corn-based kind of plastic. It's great for toys, that sort of thing, but it's a little more brittle. It's not actually that strong. I wouldn't actually recommend making anything I expect to use as a tool, but if I'm making figures or little fun things, PLA is perfect. Mm. Yes. Yeah, and there, the range of materials is worthy of an entire lecture all to its own. It really is a vast world of stuff. And so when I'm talking about, I'm usually talking about FDM or ABS or PLA, but know that it's really, it's fascinating. There's one PCB, I can't remember. They're all like 3-letter abbreviations, so they all kind of blend together. It's alcohol based, meaning that I could print it up and then using alcohol, use it to smooth things out and make it clean. Clean. You may have noticed touching that. So it's kind of rough. That's all those layers. Well, that would clean it up, smooth it up. I could take this actually and put it in a acetone chamber and vaporize acetone, and that would melt it down a little bit and make it smoother. It's probably going to smoothly sanding it. That's really what it boils down to. All right. Some things to look at, and we'll talk. We'll look at some software in a second and kind of pop out of the presentation mode for a second. But a couple things to think about with 3D challenges. And this I've been learning firsthand. The cost is a little high to get into it. Printers aren't cheap. You may have noticed this one. I think it's like 10K. That's average. And so when it comes to accessing 3D printing, that's where places like this place and our entrepreneurship center that have access to 3D printers really can make a difference. If you have access to a 3D printer that you can use it, because that investment, you don't have to take that hit. I have a network of people all around, all different type of printers, and it keeps me from having to buy more printers. I have 4 at home. That's my limit. My wife says no more. If I get more, I have to get rid of the other ones. And I agree. You're right. I have a problem. I've been buying printers since 2012. My first one was a MakerBot Replicator 5, which is just a regular one, and it still works. Other thing to note with design, there's a little bit of learning curve, and the most important thing to talk about, maintenance. These printers will break down. They always will break down. They constantly break down. If you go through a month, thank you. If you go through a month without it breaking down, you have won the prize. Go check out a lottery ticket. But because 3D printing gives you these kind of results. Oh, sorry. And that is what goes wrong. See on the top left corner? That's called the ball of death. It's a worthy name. I've had it occur to me twice. The ball of death is literally a ball of filament that gets stuck on the head, and then it just builds up and builds up and turns into a big old ball, and it's stuck on there. And I still have a little bit of PTSD after dealing with that one. That's December 19th. I remember that day well. I was really upset because that screwed up my entire printing process and my entire timeline. and a month of repairs and hundreds of dollars of parts, and now it's back up and running. A little upset about it. But see this big giant can of trash? That's all the broken, messed up prints for this guy. it's a lot of waste. And that one in the middle, it's another piece. You see that giant crack there? That was another day the snow came, and that was it. As much as I tried. So let's take a look at some 3D printing stuff here. Oh, my mouse is asleep. There it is. All right, Fusion 360. Then you seen this one? Has anyone else used Fusion 360 or tried this at all? It's an engineering style program, but it's also, I think, user friendly enough that you can kind of find your way. You can build like this whole design for this working toilet has been worked in the software. I don't want to try and sell it, but you as students you do get access to this for free, and so you should use it if you can. It's a pretty straightforward, simple thing, but I want to do this quick demonstration of doing a real quick design. I'll do kind of a recreation of the methadone drip device. This is a real easy one, something I can do within a minute. But for example here, I'm just going to do this. I'm going to create a sketch, and what does that mean? Well, I need to draw something on the screen. Pretty soon I can tell that you have the AI commands, they make me this thing and it'll pop in there, but that's not here quite yet. So with my design of that methadone drip holder, you remember it was just emulating a pen cap, right? It was just a regular old pen cap. So using precise measurements, I would measure, okay, well, how big is the tube? How big is the pen cap? What is it I'm trying to do here? And with that information, I can go here, draw. So let me just do that real quick. First, I'm going to put in, well, how big was that tube? I don't remember off the top of my head. I'm going to play loose and fast with my numbers, but don't hold it against me. Let's say it was a 10 millimeters. I just draw a 10 millimeter circle. That's the outside ring of my little tube. Okay. I want something to hold that tube. So the tube's going to be stuck in that 10 millimeter tube. I need a shell to go around it. So how thick is that shell? Okay. Just going to create another one, circle. And we'll make that 13 millimeters. Okay. Easy enough. Now I have this sketch. I got two little circles. Like, that's fun, Josh. Okay. Well, I want to turn this into, let's say, a cylinder or a channel. I hit E for extrude. I take this guy and turn it into a 30 millimeter tube. Now I could stick the tube into. It's just a holder. I mean, there's a little more nuance to it that, but that's as simple as it. That's a good, simple, easy example. It's simply measurements and shapes and a process of extrusion. Now, of course, we can do a lot more interesting and detailed, complicated stuff, but I just kind of want to show you that most of 3D design is exactly what I showed you. It's a drawing that you extrude a shape from. That's the core of it. And of course, we can get more complicated curved stuff, like tapers, we can add little holes to it, whatever. But that is the core of the design. It's like we're starting with a two-dimensional shape and doing something with it. So this 25 millimeter shape, let me add a little taper there. Oh, look at that, it turns into interesting something else. Turn that down a little bit. There we go. So now that's more like like a nozzle. That's essentially, I just made a nozzle. And that kind of stuff you kind of build up on. This shape right here, this little 25 millimeter tall with the 10 millimeter inner circle and the whatnot, I can take this shape and throw it on the printer right now. That's ready to go. Ready to print. So how would I do that? Okay. Let me export this guy real quick. Let's save as a mesh. This is just a little hyper details. When you're exporting a file, STLs are your standard kind of file shape. OBJs are fine too, but STL is good. And I'm just going to drop this right on the downloads folder. All right. So Josh is going, I'm going to take this thing out and I'm going to go into this software. Look at the preview. So this is the software for this printer right here. This is what's called a slicer. So think of it this way. So I have my shape, and what it needs to know is it needs to slice it. It needs to take the thing and say, okay, well, from beginning to top, how do I draw this thing? So let me show it to you. Let me add this real basic shape I threw on here. I'm going to import it in. It was on downloads here. There it is. So this came in as I imported it. A couple things to note. Is that the best way to print this thing? Maybe not. Why is that? Well, I got the smaller part on the bottom and the bigger part on top. Think about this. And you think about it as you're looking and listening at this thing as it's churning away. Every layer is coming down, draws it, does some other thing inside, comes up and draws it again. A little bit bigger, a little bit wider. It's all sticking to this build plate. Well, if you think about it, what's going to stick better? Something with smaller or greater surface area. Well, it's going to be the greater surface area. So I would probably flip this over. Use these little toggles here. There we go. That's going to print a lot nicer, at least in my view. Could I print it this way? You know, sitting on its side. Sure. But what's wrong with this? I got this big kind of gap. It's going to need to put in supports to fill in that empty space because it can't print in the midair. I don't know if you tried, you know, just taking your hot glue gun and just kind of waving it in the open. It's just going to spray out everywhere. And when these printers make what I call a spaghetti mess, it's spectacular. It's just filament everywhere. That'd be a good photo log. So the best way to print this guy would be to take it, print it this way. Why? Because it has better surface area. This thing will have no supports to it. I guarantee that, because it has no draft, nothing sticking out the sides. This would be a clean print. Probably, before I print up, I'm going to take a guess. It's going to take an hour and a half. All right, let's find out. So once I have it lined up, I go in here and hit print preview, and it's going through. It says, based on this orientation, I'm going to calculate how this layer, this layer. I think it was 25 millimeters tall, if I recall. It's going through all those steps, and there's the preview of it. And there it is, showing me the simulation of how it's going to print up from beginning to end. 126 layers. I was totally wrong on that time. 35 minutes, man. I was doing better earlier in the week with my predictions, not today. But this is kind of nice. You can kind of see the simulation. You may also notice this little kind of double triangle thing out here. This is kind of, I forgot the technical term for this. Essentially, as it's printing, it uses this kind of side thing as a way to kind of wipe its own nozzle. It's kind of help to keep your print clean. And if you take a look in here, as you can see, I got lots of little stringy thingies everywhere. It's not my best print. So 35 minutes later, this would be done. And that's pretty much what it would look like. I would queue it up and send it over there. That is the quickest little 3D printing workflow I can demonstrate. It's really two parts, right? We got the design, we find the design, and then we bring it into here and we slice it. Slicing is kind of, like I said, slicing it from bottom to top. How do I go? How do I go? And then printing. Once it comes out of the printer, depending on how you printed it, the supports you use, the material, will also determine how much cleanup you have to do. Now, you remember from my picture from this thing, you saw that big giant pile of white stuff everywhere? When I printed this guy, I remember this is multiple parts here. So I printed this guy. I printed them like this. I wanted to print them like this because this would have used the least amount of material, but every time I got up to this point, it kept messing up. I didn't like it. I printed it like this because I wanted to print with less supports as possible. So all of this, if it was laying like this flat on the bed, all that curved area with straight solid support, it was solid. That took me 3 days to clear out. Now, that was because I was printing the supports as the same material as the actual product. So it was ABS supports on ABS printer. And what does that mean? Well, Josh gets to make a big mess and spend days scrubbing and cursing at it. Well, this material that we're printing on this setup, this printer has this nice little material called rapid rinse, which is a water-soluble filament, meaning that all of the supports are printed with that water-soluble filament. So then I could take this printout, dunk it in a big bucket of water, and those supports would just magically go away. I wish I had done that. It would have probably cost me $200 extra. I was thinking I'm gonna hammer through it on my own. In retrospect, I probably should have paid $200. Things experience or takeaways. Hopefully, I can communicate to you. One, when prototyping these things, you have to kind of key takeaways. It was a lot of hard work. It was a lot of hard work with unknown outcomes. I had no idea what tomorrow was going to bring with some of these issues and some of these problems. So you have to kind of anticipate a little bit of uncertainty in your day. So after a while, at first when you get into it, it's kind of, you're like, oh, I don't like that. But then eventually you start to kind of crave it. Common mistakes to avoid in the process: do your research, do it. Spend the time, do the reading, look at things, go to Reddit. It's terrible, but it's good at the same time. I learned some things there. I don't like watching the YouTube videos. I prefer reading, but some of the YouTube videos are actually decent, but people spend too much time talking about things I'm not interested in. So it's a mix of time spent. And getting help. This is probably the most thing I needed to learn the most. Because when it came to this project, I came to that level where I'm like, my designs weren't really working that well. And I had to hire a mechanical engineer to take me over the hump. It's worth it. Network, that printer I found, my friends in Salisbury University Sculpture Department. That network saved me the most cash, and that was a big thing. Meeting people, knowing things, and then places like here in maker spaces where you have access to gear, access to equipment, and people are interested in using it. You leverage that. Maker spaces, part of one of my core mission, at least at the Rommel Center, is to promote the use of maker spaces as a conduit for businesses, small entrepreneurs to do exactly this, because they took the hit of the cost of the printer. They take the hit of having to fix the things, clean the things. Well, I mean, maybe it's a shared thing. I mean, you do pay for the services at a commercial maker space, like the Marvel Maker Space up in Salisbury. You pay a subscription fee to join the place, but you get access to the machines, you get access to the time, and places like this where it's kind of covered and part of the the place supporting the businesses, supporting the entrepreneurs, utilize it. So this guy's done. It's kind of fun. Oh, I forget, this guy's a little hot right now. It's 100 so degrees. It needs a minute to cool down. Otherwise, I touch it and singe myself. I don't want to do that today. All right, I'll let that cool. And best practice when you're starting into prototyping, this is one I had to get accustomed to saying. That's my nice way. Embrace risk while mitigating consequence. Embrace failure. Embrace the fails, because it will. It always will. I've never had anything go smoothly except for the methadone thing. That was this because that was simple, but it's going to fail, and you learn from every iteration. I learned that I was motivated to make this product timely, at least get my deadline to get the thing done, to make it actually print. And so, oh, this would be used like in a stadium, or this one's designed for BWI bathrooms. So it would be in any place that has commercial, well, it has public access, public toilets. And her vision was to reduce waste using the paper products. Well, I think her vision was, I want a clean experience using the bathroom. I think that was their primary goal. But then thinking about the paper that's being used for each use, or other people have different systems. And just the kind of a side note, when I was looking at this project, I did research for what else is out there. Who else has a self-cleaning toilet? There's a couple out there. The best one was ridiculous because it's something you can never implement. It was essentially a Dutch company. They had they had this big kind of cage go over the toilet, kind of a car wash thing. The toilet was clean, don't get me wrong, but they had to have this entire mechanical infrastructure to do the thing. It's not practical. It's not something they did it for like outdoor events and that sort of stuff. And there was another one, New Orleans airport. They have self-cleaning toilet seats, but they're not really self-cleaning. They're just a plastic sheet that comes out and feeds out. And I'm like, oh, that's gross. So I heard that. I'm like, oh, I don't know what that. I saw it. I'm like, and that's not reducing. That's making more waste. It's plastic. So I think this would be more for like stadiums and airports. Yeah, military. On the plane, it's probably too big for the plane. Came smaller, and it didn't. And if it was plugged into the electronics of the plane, you could not bring the batteries on it because this is battery powered. Because it's all those little considerations, but that's a possible market. That's something that is more kind of the future, hopefully. Knock on wood. Yeah. So yes and no. This is a good question. In my first picture, you saw that one really colorful green lady. That's imprinted in color. That's on a special printer called SLS printer. Oh no, I'm sorry, it's a PolyJet printer. I might take it back. It's a PolyJet printer, which is like an upgrade to the SLS printer. What does that mean? This figure, I sculpted it and I did all the color design in the computer. And when I took it to that slicing software, it sliced it, and when it prints, I'm using my hands as a guy. So imagine it prints in this kind of thing of, it's gypsum, it's like plaster. It prints a layer of blank plaster, and then it prints over it like an inkjet printer color mixed with the catalyst that hardens. So each layer, that green outline, over and over again until it finally comes out. And actually, that piece comes out in this big kind of bin of dust that you have to kind of go in there and play archaeologist and pull it out of the dust, brush it off, clean it off, and then you do some post-processing, but it comes out pure color. Those are rare and expensive. Even though it's a nice, colorful figure, I would never use it as a tool or anything like this, but as a decorative object. We do a lot of little figures of students. They can come in and we scan them, do a little pose, and they get a little figure out of it. The guy in the bottom left, that was printed in, that's video projection. That's color coming from a projector. So that's just blank white. And the red one, I just painted that. So usually it comes out in the color of filament that you load in here. Like Here, this is a black filament. Kind of see. So yes, it's only going to come out in black. But there are printers now. Prusa, and there's so many brands now. They have like multicolored heads, so they have like you'd put like 5 or 6 different colored rolls on there. It adds to your design processing, but you could print this part in red and this part in green, that sort of thing, all in one shot. Otherwise, you have to print them separately and then assemble them, which is usually the case. Because when you get multiple heads, what else could go wrong? More heads to clog, more heads to think. But the effects and the cool things are really cool. It's a burgeoning industry. It's, like I said, been around since the 80s, but it has in the last 20 years or so has kind of ballooned up into something very unique, and I think very useful for artisans, entrepreneurs, anyone who wants to make something to do. With a note on that, you asked about the production capabilities. Something I want to bring up: injection mold making. You've heard of this? You can use 3D printers, that resin printer, the SLA printer, to make injection molds. So then you can do mass production from your 3D printed model. That's a workshop I'm developing right now that I'll be posting ideally at the end of the summer or beginning of fall to do injection mold making workshops. So that kind of ties into this part, which is me. So so our makerspace, the Richard Bernstein Makerspace in the Rommel Center, we do 3D design workshops, do hands-on training, and that's something that doesn't necessarily have to be there. That's something I've been kind of spreading out, going to different areas, these type of workspaces workshops where we sit with programs like Fusion 360 or Mesh Mixer, and then learn and make things. Usually I encourage people who have projects to come in and with their ideas, and we kind of work them together. For example, I can look at these are from my classes in the past. Let me go Roberts here. He came in my class and made this. He made a lamp, essentially. Yeah. It's got a couple extra copies in here. Essentially a lamp designed and 3D printed in the class and built. That's kind of one of the things that people made. Another good example here is where's this guy? This is from a guy who has a little sailboat that they don't make parts for anymore, and he needs replacement parts. And so we just went in there and drew out what he needed and 3D printed it for him. He has his dome lights, and this is a panel for one of the outdoor things. So we're finding kind of interesting uses. It's kind of interesting when people come in and share with and what I want to make. And so that's one of the things we like to do in that class. So the archives. Let me show you this one. Yeah, check this out. She is a biology student and wanted to make a mask using a model of a pig skull, using this and Blender together to model and build this thing. which actually turned out pretty impressive, I thought. So those are kind of things that people are exploring, but I was kind of showing more of the products and things like that. But all of these are possible with 3D printing. It's an interesting and expanding world of stuff. Right. So for everyone that's interested, we do at the Rommel Center, as you kind of heard, we do get folks that come through and they're not necessarily incubated clients. They just come through the makerspace and want to participate and use the machines, and we encourage that. All we do is you come in, I'll show you how to use or set up, and then you get to play with it, or actually do it. The only thing we do limit is well, the scope. I mean, 3D printing stuff, that's fine, but if you're like, I'm making 10,000 of these things, like, you probably want to go to commercial service for that. You have to kind of balance that out. And we'll kind of work with you as well. And in addition, I myself, Joshua Killen, I have my own LLC. That's why I set up to build this thing and do this sort of thing. I also do freelance consulting work in this sort of area. So outside of working at the Rommel Center. And that allows me to do these kind of projects and other projects. Another one I'm working on now is at Snow Hill, Furnace Town. Here's that thing. So getting a digital render or digital scan of the tower, and then 3D printing a model of it for education purposes. They're gonna have the tower so that we can they can bring it out and do whatever, this is how it used to work, sort of thing, and talk about it. So that'll be a fun project where we get to go around with the drone and take pictures of it and go with a handheld scanner, something like this, and getting detailed pictures of certain aspects of the thing and squishing it together, make a nice big 3D model and printing it for fun and education. But any other questions? I'm happy to hang out and discuss, and we can play with stuff if you want and touch stuff on the computer, but let me know and we can hang out. But if you're interested,